This versatility stems from its extensive libraries and frameworks, which provide pre-built modules for various tasks, saving you time and effort. Python frameworks automate the implementation of several tasks and give developers a structure for application development. Each framework comes with its own collection of modules or packages that significantly reduce development time. Python's libraries and frameworks equip you with the tools you need to tackle diverse programming challenges. For instance, for data analysis, Python libraries like Pandas and NumPy provide powerful tools for data manipulation, cleaning, and analysis. Pandas allows you to work with data in a tabular format, similar to spreadsheets, making it easy to organize, filter, and analyze data. Python libraries are collections of pre-written code and functions that extend the capabilities of the Python programming language. NumPy, on the other hand, provides support for numerical computations and working with arrays, which are efficient structures for storing and processing large amounts of numerical data. For web development, Django and Flask make it easier to build web applications. Django provides a comprehensive framework with built-in features for handling user authentication, database interactions, and URL routing, making it suitable for complex applications. Flask, on the other hand, is a more lightweight framework that gives you more flexibility and control over the structure of your application. For artificial intelligence, scikit-learn and PyTorch provide the building blocks for creating machine learning models. Scikit-learn offers a wide range of algorithms for classification, regression, clustering, and dimensionality reduction, along with tools for model selection and evaluation. PyTorch is a powerful library for building and training deep learning models, enabling you to tackle complex tasks like image recognition and natural language processing. Moreover, Python has a large and active community of users and developers. This means you can easily find resources, tutorials, and support online if you encounter any problems or have questions. The strong community support makes learning Python a more collaborative and enjoyable experience. Real-world scenarios. Python in action. To further illustrate the practical applications of Python, let's consider a few more fictitious but realistic scenarios. Scenario 1. A social media analyst aims to understand public opinion about a particular brand on a popular social media platform. To do this ethically and responsibly, they utilize Python libraries that provide tools for accessing the platform's API, Application Programming Interface. These APIs act as a controlled gateway for retrieving data, ensuring compliance with the platform's terms of service. Scenario 2. A financial analyst wants to automate the process of generating reports on stock market trends. They can use Python libraries like yFinance to download financial data, perform calculations and analysis, and generate reports with charts and graphs. yFinance provides a convenient way to access historical and real-time stock market data from Yahoo Finance, enabling you to perform technical analysis, calculate financial indicators, and generate insightful reports. Scenario 3. Teacher wants to create an interactive quiz for their students to test their knowledge on a specific subject. They can use Python libraries like tkinter to create a graphical user interface for the quiz, store questions and answers, and provide feedback to the students. tkinter provides a set of tools for creating windows, buttons, labels, and other graphical elements, allowing you to build interactive applications with a user-friendly interface. These scenarios showcase the diverse applications of Python in various fields. Its versatility and ease of use make it a valuable tool for professionals, researchers, and students. Addressing opposing viewpoints, navigating the programming landscape. While Python is an excellent language for beginners, some might argue that starting with a lower-level language like C or C++ provides a deeper understanding of how computers work. While this argument has some merit, it's important to remember that the goal for beginners is to grasp the fundamental concepts of programming first. Learning a complex language initially can be overwhelming and discouraging, especially for those with limited experience. Python's simplicity allows beginners to focus on the logic and problem-solving aspects of programming without getting lost in the intricacies of memory management and hardware interaction. It's like learning to drive a car with an automatic transmission first, before moving on to a manual transmission. Once you understand the basic principles of driving, you can delve into the more complex mechanics if needed. Once beginners have a solid foundation in programming principles using Python, they can explore lower-level languages if their career paths or interests require it. This approach ensures a smoother learning curve and a more positive and engaging experience with programming. Ultimately, programming is about instructing computers to perform specific tasks using languages they understand. Python, with its readability, versatility, and strong community support, is an ideal starting point for aspiring programmers. Its simplicity allows beginners to focus on core concepts and build a strong foundation in programming logic. As you begin exploring the world of programming, remember that practice is key. The more you code, the more confident and proficient you'll become. So embrace the challenge, explore the endless possibilities, and welcome to the exciting world of programming.
The simplest definition of programming is that it's the way people communicate with computers and instruct them to perform tasks. But programming is anything but simple. When you've completed this video, you will be able to define programming and programming fundamentals, and describe how programming can break down problems into smaller steps, using code to find solutions and discuss how programming impacts everyday life, such as apps, games, websites, and self-driving cars. But let's start with the basics. Programming can be defined as the art of writing instructions for a computer to execute, telling it what to do, and how and when to do it. These instructions are written in a programming language, like Python. Programming fundamentals are the core elements or concepts that programming is made up of, regardless of the specific programming language. These fundamentals include variables, data types, operators, control flow statements, and functions. These foundational concepts provide the building blocks for creating programs. Let's take a quick look at these fundamentals. Variables are like containers that store data in your computer's memory. They allow you to give names to values, making it easier to reference and manipulate them throughout your program, making your code more organized and readable, so it's easier to understand and modify. Data types define the different kinds of data a variable can hold. Common data types in Python include integers, which are whole numbers such as 0 or 10, including negative numbers like -5. Floating point numbers, which are numbers with decimal points, positive or negative, such as 3.14 or -2.5. Strings, which is text enclosed in quotes, like quotation mark, hello, end quote. Booleans, which are representations of true or false values. You need to use the correct data type for each piece of information to make sure your code behaves as expected. Using the correct data types also prevents errors. Operators are symbols that perform operations on data. They are the tools you use to manipulate and transform data in your programs. Common operators in Python include arithmetic operators for addition, subtraction, multiplication, and division. Comparison operators, like greater than, less than, equal to, and more, that are used for comparing values. Logical operators like and, or, and not, which are used to combine conditions. For example, the shape is blue and triangular. Control flow statements determine the order in which your code is executed. They allow you to create branches in your code's logic, execute code repeatedly, or make decisions based on certain conditions. This enables programs to respond to different situations and user inputs. They include conditional statements, like if, elif, or else statements, which allow you to execute different blocks of code based on whether a certain condition is true or false. Loops, which allow you to repeat a block of code multiple times. Functions are reusable blocks of code that perform specific tasks. They combine a series of instructions, breaking down complex tasks into smaller, more manageable units. This makes your code more organized, efficient, and easier to maintain. They also reduce redundancy. You can call the same function a number of times, but only have to write the code within the function once. Programming fundamentals help you break down problems into smaller, more manageable steps, which is a logical and analytical approach to problem solving. Another advantage is that fundamentals help you write efficient, optimized code that performs well and consumes minimal resources, so you can build applications that are fast, responsive, and scalable. Here's an example of using code to solve problems. Let's say you're hired to write a program that analyzes customer purchases from an online store. You break this into steps. Step 1, obtain the customer purchase data. Step 2, clean the data. Step 3, transform the data for analysis. Step 4, identify trends, patterns, or insights in the data. Step 5, present the results so clients can make decisions and solve problems. Your Python code was used in every step, using variables to store data, loops to iterate through the data set, conditional statements to make decisions, functions to encapsulate reusable logic, and libraries like pandas and matplotlib for data manipulation and visualization. But the most compelling reason for an aspiring Python programmer to understand the fundamentals is the fact that programming is all around us. We use it every day. There are mobile apps for social media to connect with people, for games to entertain us, for productivity tools, and the list goes on. Then there are the websites we browse, the online stores we shop from, and the search engines we use. All of them are built and function by and because of programming. Programming even controls the way traffic lights provide safety at intersections, makes surgical tools perform, and even enables self-driving vehicles to understand their surroundings and make decisions. And all of that is waiting for an aspiring programmer like you.
This website code is so difficult to work with.
What did you say?
Every time we try to make even the tiniest change to the code, it takes hours.
Yeah, this legacy codebase is outdated and difficult to maintain.
We're constantly fixing one error, only to have another one pop up.
You know, I've been reading a lot about Python lately. It's supposed to be a much more efficient and maintainable language than we're currently using.
Python? Isn't that mostly used for data science and machine learning?
Python is actually incredibly versatile. It's great for web development too. Some companies use Python's Django framework to handle millions of user interactions and posts every day. And large websites rely on Python for their scalable web infrastructure.
Python can handle that kind of traffic?
For sure. It's not just about web development either. Companies use Python for data analysis to make personalized recommendations. In healthcare, Python is used to analyze medical images and detect diseases.
But what makes Python so much better than what we're using now?
Python's syntax is easy to read, unlike our current programming language. And because it's so easy to read and write, you can make changes much faster.
Wouldn't it take a lot of time and effort to rewrite the entire website in Python?
I think it would pay off in the long run. Companies even use Python to automate repetitive tasks, saving countless hours of manual work. We could gradually migrate parts of our site to Python and see how it goes.
Maybe it's time we gave Python a shot.
I think it could be a game changer for us.
All right, let's do it. Time to update this website using Python.
Okay. everyone. You know that I'm looking for a job too.
Python has become a popular and useful programming tool. Its syntax, readability, and libraries have made it a go-to choice for many
Blue eyes.
applications, from web development and data science to automation and artificial intelligence. In this video, we want to introduce you to Python, its history, philosophy, and key characteristics. By the end of the video, you will be able to explain what Python is, discuss its history, philosophy, and versatility, and talk about how Python supports object-oriented programming. Let's start with a little background. Python was created in the late 1980s by Guido van Rossum. He wanted to make a programming language that was both powerful and accessible. His guiding philosophy centered on readability and simplicity, so that it would be an easy language to learn, even for people new to programming, yet still offer the functionality needed to tackle complex projects. This philosophy resulted in a language that often reads like plain English, making it easier to write and maintain. The emphasis on readability makes it a collaborative tool, because code written by one developer can be easily understood and modified by other members of the programming and development team, which enables more efficient teamwork and streamlined development processes. Python has 3 defining characteristics that make it a powerful and versatile tool for a wide variety of applications. These characteristics are interpreted language, high-level language, object-oriented programming, or OOP. Interpreted language means that Python code is executed, line by line, by an interpreter. This is different from compiled languages like C++ or Java, where the entire code is converted to machine code before it is executed. Python's interpreted language lets you run your code and see the results instantly, without the need for a separate compilation step. This accelerates learning and experimentation, something that makes Python a good choice for beginners and experienced developers. As a high-level language, Python simplifies many of the complexities of lower-level languages, allowing you to focus on the logic of your program rather than the details of how the computer executes it. Python operates at what's called a higher level of abstraction, meaning it shields you from the intricacies of low-level machine code. This simplifies the coding process and makes Python code more readable and maintainable. The third characteristic is that Python supports object-oriented programming, or OOP, which is a programming paradigm that organizes code around data structures that contain both data and functions. These are called objects. Objects promote code reusability, modularity, and maintainability, making it easier to manage and scale large software projects. It kind of works like a child's building blocks. Each building block object has its own specific function, and they all snap together to create a cohesive whole. In addition to these characteristics, one of Python's greatest strengths is its versatility. It's a general purpose language, meaning it can be used to build almost any type of software application, and is capable of handling a wide spectrum of tasks across diverse domains. Here are a few real-world examples of Python applications. The first example is web development. Python frameworks like Django and Flask provide a structured foundation for building web applications. Django's batteries included approach offers several built-in features that simplify common tasks, like database management and user authentication. Flask, on the other hand, provides a more minimalist framework, which gives you greater flexibility and control over your project structure. In data science and machine learning, Python offers several built-in libraries, including NumPy for numerical computations, Pandas for data manipulation and analysis, and scikit-learn for machine learning algorithms. These libraries, coupled with Python syntax, empower you to extract insights from data, build predictive models, and unlock the potential of artificial intelligence. Another example is for automation and scripting. Python allows you to automate workflows, streamline processes, and build custom scripts tailored to your needs. Automation can be used for file backups, sending customized emails, or scraping data from websites. Python's versatility also has applications in game development, scientific computing, education, and many other fields. This broad applicability means you can always find new ways to leverage your Python skills, making it a valuable asset for programmers of any experience level. As you can see, Python is a versatile, high-level interpreted language that can serve a wide range of applications. So, whether you're new to programming or are already an experienced developer looking to expand your skill set, Python is a good language to add to your programming and development expertise. In addition to its user-friendly natures and variety of libraries, Python also has a thriving virtual community of users who share their knowledge, ideas, and expertise with each other to grow and progress.
is calculated area correct?
True, but
Okay. If I get it right, you get $100. If you get it right, I get $100.
my wallet?
Yeah.
Okay, cool.
Okay.
Easy money, okay?
Yeah.
2.
Thank you. It's not even your it's even just came from your from what you call that? From your ads. You become broke from watching ads.
Is that right then?
Python has steadily risen to become a dominant force in the programming world because it prioritizes clean syntax and readability. Its code often resembles plain English, which allows you to focus on solving problems rather than wrestling with complex syntax. Yet, despite its beginner-friendly nature, Python is far from a toy language. Its versatility and extensive libraries allow it to tackle complex projects in web development, data science, machine learning, and much more, putting it on par with, and often exceeding, the capabilities of more established languages. The beauty of Python's syntax. One of Python's most celebrated features is its clean and readable syntax, a stark contrast to some other languages that can feel cluttered with symbols and rigid structures. In Python, you won't find a tangle of semicolons or curly braces dictating code blocks. Instead, Python relies on indentation, using spaces or tabs to define the structure of your code. This not only makes Python code look more like plain English, but also enforces a consistent and organized style that's easier to understand and maintain. Let's take a look at a simple greeting message. Code block. See reading page for details. This single line does the job beautifully. But to truly appreciate the power of indentation, consider this example that demonstrates a condition, which will be discussed in a future reading. Code block. See reading page for details. In this code, indentation is crucial for several reasons. Conditional statements. The lines indented under if and else within the code define the different actions Python should take depending on the conditions met. The indentation clearly separates these different paths of execution. Readability. Even without knowing Python, you can probably guess what this code does because of the indentation. It visually groups related actions together, making it easy to follow the logic. Now let's contrast this with code that lacks indentation. A code block. See reading page for details. This code lacks indentation, is a jumbled mess, and is more difficult to understand. Python would also throw an error because it relies on indentation to parse the code correctly. The indented version is not only more visually appealing, but also essential for the code to function as intended. Data types. The building blocks of your code. Data types are like the different tools in a toolbox, each designed for a specific purpose. Just as you wouldn't use a fork to eat soup, you wouldn't use a string to store a number in Python. Understanding the right data type for the job is essential for writing effective code. Here are some essential data types you'll encounter, along with scenarios where they shine. Numbers. For storing numeric values like your age, 25, the price of a product, 19.99, or the number of students in a class, 30. You'd use integers for whole numbers and floating point numbers for decimals. Strings. When you need to work with text, such as someone's name, Alice, the title of a book, The Hitchhiker's Guide to the Galaxy, or a message you want to display on a website, welcome. Strings are your go-to choice. Booleans. Imagine you're building a quiz app. You need a way to track whether an answer is correct, true, or incorrect, false. This is where Booleans come in handy, representing logical states. Lists. Think of a grocery list. It's an ordered collection of items like milk, eggs, and bread. Lists in Python work similarly, allowing you to store multiple values in a specific order. This is useful for things like keeping track of high scores in a game or storing the names of all your friends. Dictionaries. Let's say you're creating a profile for a user. You want to store their information, like their name, age, and email address. Dictionaries are perfect for this, as they allow you to associate values, like Alice or 30, with keys, like name or age. Python's strengths for beginners. Python shines as an ideal starting point for aspiring programmers due to a unique blend of features that simplify the learning process and empower beginners to achieve meaningful results. Unlike some languages notorious for their steep learning curves and cryptic syntax, Python's code resembles plain English, making it far more approachable for newcomers. This readability not only reduces the initial intimidation factor, but also fosters a deeper understanding of programming concepts, as learners can focus on logic rather than wrestling with complex syntax. Moreover, Python's supportive and extensive community acts as a virtual safety net for beginners. The wealth of tutorials, forums, and resources available online ensures that learners never feel alone in their coding journey. Whether you're stuck on a bug or simply seeking inspiration, the Python community is always ready to lend a helping hand. Python's versatility is another major draw for beginners. Unlike languages that pigeonhole you into specific domains, Python empowers you to explore a wide range of programming applications. Whether your interests lie in web development, data analysis, automation, or even machine learning, Python provides the tools and flexibility to turn your ideas into reality. This versatility opens up a world of possibilities, allowing beginners to discover their true passion within the vast landscape of programming. One of Python's most significant advantages, especially for those new to coding, is its rich ecosystem of libraries and frameworks. These pre-built tools act as shortcuts, enabling you to accomplish complex tasks with minimal effort. Need to create stunning data visualizations? There's a library for that. Want to build a web application? Python's got you covered. This abundance of resources not only accelerates development, but also allows beginners to tackle ambitious projects that would otherwise be out of reach. Furthermore, the rise of generative AI tools has added another layer of appeal to Python. These tools, seamlessly integrated into many Python development environments, are revolutionizing how programmers work. Code generation. AI-powered code completion tools like GitHub and Copilot act as intelligent assistants, suggesting code snippets, functions, and even entire classes as you type. This not only saves time, but also helps beginners learn new patterns and best practices. Debugging assistance. AI-powered debugging tools, such as those found in modern IDEs, can automatically analyze your code for errors, suggest fixes, and even explain the underlying issues. This can be a game changer for beginners who are still learning to troubleshoot their code effectively. Learning aid. Generative AI can serve as a virtual tutor, answering questions about Python concepts, providing examples, and even generating personalized learning materials based on your current skill level. This interactive and adaptive learning experience can accelerate your progress and make learning Python more engaging. Creative inspiration. Even for experienced developers, generative AI can spark new ideas and suggest alternative approaches to problem solving. For beginners, this can be particularly valuable as they learn to think like programmers and explore different ways to implement solutions. While other languages like C++ or Java may offer performance advantages in certain niche scenarios, they often come with a trade-off in terms of complexity and learning curve. Their syntax can be dense and unforgiving, their tooling less intuitive, and their communities less welcoming to newcomers. Python, on the other hand, strikes a harmonious balance between power and simplicity. Its readability, supportive community, versatility, extensive libraries, and embrace of AI tools make it the ideal companion for those embarking on their coding journey. In essence, Python is not just a programming language, it's a gateway to a world of possibilities. It's a language that empowers beginners, nurtures their creativity, and sets them on a path toward becoming proficient and confident developers. So, if you're ready to embark on an exciting adventure into the world of coding, Python is undoubtedly the best place to start. It's a language that welcomes you with open arms, guides you through the challenges, and equips you with the skills and knowledge needed to thrive in the ever-evolving landscape of software development.
Python has sometimes been called the Swiss Army knife of programming languages because of its adaptability. It can be used effectively in a wide variety of situations, such as web applications, data handling and manipulation, and even advancements in artificial intelligence. By the end of this video, you will be able to discuss how Python can be used in real-world applications. As a Python programmer, don't expect that you'll be doing the same thing all the time. time. The language's adaptability and capabilities have made it the tool of choice for developing programs and applications in several different disciplines. These include web development, data science, automation, machine learning, and other specialized fields. Let's talk a little bit about Python's uses in these areas. Python has made a big impact in the field of web development through its frameworks like Django and Flask, which streamline the creation of dynamic, scalable web applications. Django is a framework that focuses on rapid development and clean design to simplify common web development tasks like user authentication, database management, and URL routing. This frees programmers and developers to focus on building an application's features. Notable examples of Django-powered websites include Instagram, Disqus, and Spotify. Flask, on the other hand, is a micro-framework that provides the essentials for building web applications while giving developers more control over the underlying structure. Flask's simplicity and extensibility have made it popular for smaller projects and for developers who want to fine-tune every aspect of an application. Data science encompasses a wide variety of tasks, from collecting and cleaning data to analyzing, visualizing, and drawing actionable insights. Python includes a series of libraries designed to help you perform these tasks more effectively, such as Pandas, which is a data analysis library that provides intuitive data structure.
Alright, what do you want?